When we think of stars, we often picture small twinkling specks in the night sky. This is the way we observe them from Earth. However, stars like Betelgeuse are vastly different. In fact, Betelgeuse is so gigantic that it far surpasses our Sun in size. This star has perplexed scientists for a long time. Recently, though, new developments surrounding Betelgeuse have raised more concerns among researchers. In this video, we explore the latest updates about Betelgeuse, including its anticipated end as predicted by the James Webb Space Telescope. We will also discuss how these events might affect both our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a fascinating cosmic wonder, an enormous star that has intrigued astronomers for many years. The initial discovery of Betelgeuse was made by the Greek astronomer Tycho Brahe. This star is so vast that it can be seen in the evening sky from Earth, particularly during the winter months. If you're passionate about astronomy, you've likely heard of it. Betelgeuse is the bright reddish-orange star that marks the upper left shoulder of the Orion constellation. It is an ancient star and one of the most luminous objects in the night sky. However, its brightness is not constant and fluctuates over time. This variability is one of Betelgeuse's most interesting features, but it is not the only remarkable characteristic of this star. Most of the stars visible to us are extremely far away. The closest star, Proxima Centauri, is located 4.2 light-years away from Earth. If you're not familiar with the concept of a light year, imagine traveling at the speed of light for an entire year. Light moves at approximately 186,000 miles per second, and in 1 year light travels billions of miles. So when we say Proxima Centauri is 4.2 light-years away, we mean it is billions of miles from our planet. However, there are stars like Betelgeuse that are even farther. Betelgeuse lies about 600 light-years from Earth. That means if we could travel at the speed of light, it would take us 600 years to reach it. Unfortunately, we are not yet capable of traveling at the speed of light, not even with our fastest spacecraft. Despite this great distance, Betelgeuse still shines brightly in our night sky. You may wonder how Betelgeuse can be so luminous despite being so far away. The answer lies in its unique features such as its enormous size and incredible luminosity. Betelgeuse is approximately 500 times larger than the Sun, and its radius is believed to be several times that of our Sun. When observed through advanced telescopes, Betelgeuse appears more as a disk than a tiny point of light, unlike most other stars. This phenomenon is believed to be caused by the reactions happening in its outer layers. As for its mass, Betelgeuse weighs somewhere between 12 and 19 times the mass of the Sun. A single solar mass is equivalent to 2 times 10 superscript 3 kilograms. However, astronomers cannot precisely determine Betelgeuse's mass due to the lack of planets or objects orbiting it, making direct measurement from Earth impossible. The fact that Betelgeuse is many times more massive than our Sun makes it truly exceptional. Its brightness ranges from a magnitude of 0 to 1.6. In simpler terms, it is about 16,000 times more luminous than our Sun, earning it the title of a red supergiant. However, its brightness is not constant. It fluctuates due to pulsations within the star. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These cycles can last anywhere from 10 to 100 days, or sometimes even longer. Another fascinating feature of Betelgeuse is the presence of dark magnetic spots on its surface. These are areas where the magnetic field is much stronger than usual, hindering the flow of hot gases to the surface and cooling those regions. Betelgeuse has far more of these magnetic spots than the Sun, which is why it is cooler despite its greater size and luminosity. While our Sun also has dark magnetic spots, Betelgeuse's spots are significantly larger and more numerous. For perspective, some of these spots can be twice the size of Earth. Betelgeuse also has a magnetic field about 1,000 times stronger than that of the Sun. This magnetic field creates spiral or arc-like patterns on its surface when observed through a telescope. The surface temperature of Betelgeuse is approximately 3,500 Kelvin, which contributes to its low energy output and faint red color. Interestingly, Betelgeuse wasn't always a red star. Around 100,000 years ago, it had a yellowish hue similar to our Sun. Over time, it transitioned to an orange and eventually red color approximately 10,000 years ago. This transformation led scientists to conclude that Betelgeuse is aging. Betelgeuse emits up to 10,000 times more energy than the Sun. Had it been closer to Earth, it would have outshone the Sun. If it were any nearer, it might even be visible during the day. However, due to its enormous size, if Betelgeuse were to replace the Sun, it would engulf Earth and the nearby planets. Despite being 600 light-years away, Betelgeuse is still visible to the naked eye, which is remarkable. Our Sun, located just 8.3 light-minutes away, appears much brighter than Betelgeuse due to its proximity. The fate of Betelgeuse. Betelgeuse has attracted significant attention due to a series of dimming events that began in late 2019 and continued through mid-2021. During these events, the star's brightness dropped to unprecedented levels, raising speculation that Betelgeuse might soon go supernova. A supernova is an explosive event that occurs when a massive star runs out of fuel and collapses under gravity, triggering an enormous explosion that can outshine an entire galaxy. If Betelgeuse were to explode as a supernova, it would be one of the brightest objects in the sky, even visible during the day. However, recent studies suggest that the dimming was likely due to a dust cloud forming around the star. Betelgeuse often expels material, and sometimes this material clumps together to form dust clouds, obscuring the star and reducing its brightness. Even though Betelgeuse will eventually explode, this event is not expected to occur for another 100,000 years. When it does, the explosion will scatter elements like iron, calcium, and oxygen into space, enriching the interstellar medium and aiding in the formation of new stars and planets. While Betelgeuse's future supernova will be a spectacular event, there is no need to worry. The distance between Earth and Betelgeuse is so vast that its explosion would not harm our planet. However, it highlights the immense power and dynamism of stars and their role in shaping the universe. Astronomers continue to monitor Betelgeuse using advanced telescopes to track its pulsations, brightness, and changes in behavior. Understanding how Betelgeuse and other stars evolve provides valuable insights into stellar life cycles, the dynamics of galaxies, and the origins of elements that make up everything around us. In the grand scheme of things, while Betelgeuse's supernova may not occur for another 100,000 years, its eventual explosion will leave a lasting legacy on our understanding of the cosmos.